Yes, class. Good evening, all. Am I audible to all of you?
Good evening, ma'am.
Yes, ma'am.
So, who all have joined? Aisha, Aram. Aram, you were absent in the last class, no? Hiba, Maha, Tarif, Abdullah, and Talha and Yusuf. All right. So here we had stopped bending of road. So formula of the velocity came out to be under root mu r g. Now we didn't do any question from this based upon this topic. Let's practice some numericals from this. Now see class, here how did we derive it? Just a very small derivation as revision. Frictional force was the centripetal force. Frictional force completed the requirement for the centripetal force, or you can say frictional force provided the necessary centripetal force that was required for the car to bend on this road or for the bend of that road to occur. Normal and frictional force, we know it's mu n, and n can be equal to mg, and we have also seen cases where n is not equal to mg. In this case, normal reaction will definitely be equal to the weight of the body, that is mg. So n was equal to mg. From here we got v is equal to mu rg. Now we have to have the velocity less than this, it's a safe limit, or otherwise more than this, not more than this, just equal to this. This is then known as the safe limit. If it is less than, for example, let's say this term comes out to be some value, let's say 5 meter per second square. Fine. So it has to be 4.9, 4.8, 4, 3, like this. But if it crosses it, 6 meter per second square, 5.5 meter per second square, all these, then safe limit is exceeded. So maximum safe limit is under root mu r when you equate it. Let's see a question based on this. Like this question, a car is moving on a circular track. The radius of the track is given as 100 meters and coefficient of friction is given as 0.4. So radius is 100 meters, coefficient of friction is 0.4. G, we'll take it as 10 only. So here velocity is equal, you will put V max only because you're calculating safe limit, and safe limit is the maximum velocity. Maximum possible velocity is when it is equal to this. That is under root mu rg. Under root mu is 0.4, r is 100, g is 10. So that becomes under root 400, which gives you 20 meter per second. One more question we'll do based on this. Safe limit, just note this down. Then we'll do one more question based upon this. Class, so this is the same question only. Now instead of 0.4, you have 0.2. Send me your answers for the second part. All of you send me your answers for the second part in the chat box. Yes, Maha. The second answer that you've sent, that is correct. And he is also right. Mohammed Tarif. Your answer is correct. So others, where are your answers? Only two students have tried. This was a very easy and formula-based question. See, V is equal to under root mu RG. This is a continuation only of the second question. So radius, you can take it as 100 only. And G is 10. So this becomes under root 200, and under root 200 meter per second square you can write, or even you can write this as 10 root 2. So 10 into 1.414, which is 14.14 meter per second. This will be your answer. 14.14. Yes, right, Talha. Now see, same case, bending of cyclist, just one formula we have to derive, and that derivation of the formula only comes in exam. The numerical part rarely comes in the exam from that. It can come, but mostly this numerical derivation is there. See, bending of road we have seen. If bending of road is there, then what is the velocity? That is the safe limit. But if somehow the road is inclined from one edge, if the road is inclined at one edge, let's say it has inclined to some angle theta, the inclination is theta. Now your vehicle will be like this. Instead, which was directly on the road, it is slightly inclined. Now what will happen? See, this is the normal reaction. Normal reaction will always be perpendicular to the surface. And mg, that is the gravitation force, it goes downwards. Now do you see, normal reaction and mg are not equal to each other. So we had already discussed this plane inclination problems where we had resolved these vectors. So similarly here also you have to resolve the vectors, but in which direction will you resolve it? Do you still need to resolve mg? Like in the other questions, not all students know. I think Maha and Aisha, Aram, I had discussed this with you, that if this is such a case, here in this case we used to resolve mg cos theta and mg sin theta. But class C, right now you have to resolve vectors in this direction along x-axis and y-axis. So see, mg is directly falling on x-axis, y-axis. So there is no need to resolve mg now. Whereas we need to resolve normal reaction as well as friction. Why? Because friction will come in the downwards direction. Earlier, when the car was straight, friction was going towards the center like this. Now the car is as inclined. So frictional force will also incline because it will be opposite to the motion. Now see, if we want to resolve this angle will also be theta. This is theta. So this becomes theta, 90 minus theta, again 90 minus theta. So this is theta, the way we have been calculating here. Same thing. See, this is theta, right? This is 90 degrees that we have. This is theta, alternate angles. This is 90 minus theta, this part. So this becomes theta. So this is theta. Now we can resolve the vectors.